Hello, I'm Richard Hollingham and welcome to the Planet Earth podcast with news from the natural world. This week I'm on the beautiful but blustery Norfolk coast to discover why it might be a good idea to remove flood defences. We'll also be heading south to the roughest seas in the world with our latest audio diary.
I look out the window, the sea's just like frothing. It's absolutely, I've never seen anything like it. And obviously this is only force 9 out of 12, so... Right, so what I'll do, I've got my hoodie on, my gloves and all that. So now we're going to open the door, see what happens.
And discover what does happen a little later. I'm at Sea Pooling on the east coast of Norfolk. A long stretch of perfect sand is in front of me. Then behind me a hefty concrete sea wall, sand dunes, and behind that, in the village itself, an area that is below the level of the sea. And with me are environmental economist Kerry Turner and Tiziana Lucetti from the University of East Anglia. Now, Kerry, you've been carrying out research on the value of holding back the sea, what these flood defences were designed to do. What's the alternative?
Well, Richard, the difficulty we have here is that armouring the coast with various civil engineering works, large groins, rock groins, large concrete sea defences, is extremely expensive business, and basically it's not possible to continue this line of defence everywhere down the coastline for a long period of time. So we've been looking at a variety of alternative options available to us to try and more cost-effectively protect people from the sea.
So what's the alternative?
Well, what we've been looking at is at selected sites where we can use natural systems, ecosystems, to do the job of the concrete sea defences. So we're not removing protection, we're merely replacing one form of protection by another. So the ecosystems, sand dunes, salt marshes, mudflat systems are naturally in place and do give us the capacity with a certain amount of realignment to offer a protective system.
I like the word realignment. Essentially you're letting the sea in. Now, you mentioned the ecosystem. You create a new ecosystem or a replacement ecosystem. The point here is that's got a value.
Indeed, what we've been looking at are the various services that these ecosystems like salt marshes and mudflats actually provide to us humans in society. When you look closely at these systems, what we find is that they will protect in terms of sea defences, suitably arranged. They will give us fish nursery areas. They will give us a carbon storage facility in that they have the capacity to take in carbon from the atmosphere and therefore help with global warming. And they're also a recreation and amenity asset. So all these services can be given a monetary value and when added up come to a considerable sum of money which is worth protecting.
So actually, the benefits of removing sea defences, not necessarily here but in other places, could be greater.
Indeed, we found at various sites that realigning the coast, working with these coastal systems rather than trying to restrain them through concrete defences, actually works out to be a more cost-effective solution, given the right site and right location.
Now, Tiziana, your research ties in with this and in fact backs that up. What did you do?
In my research, I did a survey. So I interviewed people to see if they were prepared to pay to actually have the possibility of recreate and enjoy the salt marshes in general. In that case, we were looking at recreate salt marshes in Essex, in the Blackwater estuary. So I interviewed people in Essex, Suffolk and Norfolk, and I've been asking them through a questionnaire several questions about salt marshes, also if they were prepared to pay some pounds on top of their council tax to actually have the possibility of recreating salt marshes.
And they would?
Yes, they would. It is also quite interesting to see that they were prepared to pay either for what economists call non-use value of the land, so like for biodiversity in general, and also actually for the use of the salt marshes, which means going there actually enjoy the salt marshes, having a walk and enjoying the scenery and just relax there.
Now, Kerry, this is overturning decades of policy. I think this concrete defence, which is hefty and stretches right into the distance, was built, in the 1950s. And it's always been hold back the tide, hold back the tide, hold back the tide. That's changing.
Yes, we are not trying to radically change coastal defence policy, but merely point out that in certain locations, working with natural systems is a more cost-effective way forward. The politics of managed realignment is clearly a difficult one, and there are many locations where seawalls such as the one we're standing next to will have to be the only solution, will have to be paid for, and will have to be maintained over decades of time. But in other areas, salt marsh frontage with a secondary defence further inland is a lot less expensive and gives us these ecosystem service values that I was talking about earlier.
And this idea of ecosystem services, is that a good selling point to politicians? Rather than saying, we've got to tackle global warming for ethical reasons or for other slightly more nebulous reasons?
Yes, I think there's always been a very good ethical case and scientific case for various environmental conservation policies. What we're arguing as economists and environmental economists is that we can buttress those arguments with hard economic values which add to that conservation case. And we would argue that that type of argument tends on average to play better in the ministries of finance, both in the UK and around the world. And like it or not, it's the Minister of Finance that actually controls most of the policy.
And if your arguments are won, then would the coast of Britain look very different in a few years' time?
On average, it wouldn't. What we're saying is that in certain locations, these salt marsh areas could be extended, and along the east coast in particular of England, there are a number of very promising sites, we think, for this realignment. But we are not advocating this policy as a uniform policy for protecting the coast from the top of Scotland to Land's End.
Well, Kerry and Tiziana, thank you both very much. Around a third to a half of carbon dioxide in the atmosphere is absorbed by the oceans. But the amount of absorption depends on how rough the sea is. The mixing between air and water is greater in rougher seas than calm ones. But the thing is, most existing climate simulations or models don't take this into account. So, to measure the exchange of gases between the water and the air in rough seas, you need to go to rough seas. David Tupman from the University of Leeds has been carrying out experiments on board the British Antarctic Survey's research ship, the James Clark Ross, in the Southern Ocean. Although he's near the science station on Cygney Island, he's still a long way from home.
Okay, so it's looking pretty fruity outside, so at the minute I'm just inside the main lab where we're working, and I'll have a look at the screen. It's 36 knots out there. It was up to force 9 before on the old Beaufort scale. If I look out the window, the sea's just like frothing. It's absolutely, I've never seen anything like it. And obviously this is only force 9 out of 12, so... Right, so what I'll do, I've got my hoodie on, my gloves and all that. So now we're going to open the door and see what happens. Yeah, it's really crazy out here. Yeah, some of the waves are like, must be 6-7 metres. It's unbelievable out here. So we've got two wave buoys, which there's sets of wires and the capacitance measures the high frequency wave heights, and you've got accelerometers as well, which will measure the lower frequency stuff like the swell, and you get a good picture of the different frequencies of waves and how strong they are and how high they are. We're also deploying, it's quite a novel thing we're doing, there's a balloon with a camera attached to it basically, and we deploy that out the back and if it's stable and it's nice and all the camera settings are right, which doesn't seem to happen very often, you get decent pictures of the sea in whitecapping.
Let it out a little bit more, try and get a few different altitudes on the cameras.
Alright, we're just getting ready to launch the balloon now, so I've been able to get away from the team and get a nice vantage point. So we've got a winch set up on the deck, and the line goes down to a little mooring point just near the aft deck. It's a helium-filled balloon kite, so it's kind of waving around a bit at the minute. Ian's just walking it forward to the aft deck here. It's swinging around a bit, but not as bad as it's been sometimes. Sometimes it's been out on deck, it's been thrashing around like a spoilt child. But it's looking good. I think we're just waiting for a decent gust and it's away. Oh God, it's going to hang on. No, it's looking good. Took a little dip at first, but we're looking good here.
Try and get a few different altitudes on the cameras.
Last day of the science centre today, so we'll deploy the buoy a couple of times. Get the balloon out, perhaps, if the conditions get a bit better. We've got low cloud at the minute, so it's very turbulent. And last time we tried the balloon, it sort of bounced off the water a few times because there was some big eddies taking it down. Last day of the science, really, and then a couple of days in Sydney will help them move out and get some nice photographs and do some walking as well. Alright, so we got to Sydney and we carried boxes for a long time and slipping on elephant seal poo. But everything was okay, and I'm stood next to a big pile of them right now. And I'm looking at one of them, and he's got enormous nostrils. He keeps opening them with lots of white stuff. Ugh, that's pretty disgusting. Look at you. Oh, they're quite nice though. Very peaceful and looking right at me. And one of the seals just put its paw on top of the other one. Just like a big writhing mass of blubber. They're bigger than I thought as well. Like, there's a little seal, which I thought was like when we first got here, I thought the cub seal was like the seal and there was no others, but I thought the rest were just rocks. But then I realised they were steaming. It's quite a beautiful place. So I'm here with a little pack of seals and just want to find out how life is lying on a deck or a big grating all day. So I'll ask the first seal, so how's it like? I think translated that was just nothing. Just scratching itself now. Look at that. That's weirdly human, that. It's got like 4 fingers and a thumb type bit. And just like a lazy person scratching himself. Well, that was quite an amazing day. We went to Sydney Island. We just got back home, just had a shower, washed all the seal poo off my clothes. So I'm sat in my cabin now, just having a semi-doze sort of thing. We spent the morning kind of lifting boxes for the guys there, and I just kind of got a sense that that's the sort of thing I'd love to do. I was really inspired by meeting the guys who worked at the base. Getting into Chile now. So to the left of me, I've got these white-capped mountains, tops just hidden by cloud, and the sun's setting, so it's kind of blue in the distance. In front, where the ship's going, it's just kind of a blue, foggy mass ahead. The water's pretty still because we're in the Magellan Straits, and it's quite calm now. Which, compared to the ocean before, it was pretty rough out there. That's a nice little image there. So I'm stood looking at the exhaust from the engines, and it's just behind that you've got the Union Jack flapping away, and you got the heat lines kind of coming off the exhaust pipes, making it all shimmer. And it's quite a nice moment.
David Tupman with his audio diary from research ship the James Clark Ross. I've asked David to send us some pictures. As soon as we have them, we'll put them up on our Facebook page. To find our website and join the debate on Facebook, search for Planet Earth Online. Back on solid ground now, and the benefits of planting trees, from improving air quality to providing a habitat for wildlife, are well known. But there's also a hidden benefit. Small particles produced by trees in a forest can affect local cloud cover, producing whiter, brighter clouds. Catherine Scott from the University of Leeds Institute of Climate and Atmospheric Science is studying this phenomena. Sue Nelson went to meet Catherine to find out more.
During the life of a tree, it will take in a certain amount of carbon from the atmosphere in the form of carbon dioxide. It does that as part of photosynthesis when it also releases oxygen back into the atmosphere. But what we're interested in looking at are other gases that trees release into the atmosphere. So if you're walking through a forest, you can smell a kind of piney odour, and that's because of these other compounds, volatile organic compounds. And they're things like isoprene and monoterpenes.
What in particular are you interested in about them?
These compounds are incredibly important because when they're released into the atmosphere, they undergo reactions with a class of compounds called oxidants, and that's things like ozone. Following those reactions, they're able to form tiny particles in the atmosphere via a number of different mechanisms that scientists are still trying to get a clear idea about, but we know that happens. So it's the impact on the climate of these particles that we're really interested in looking at.
So what role do these particles play then?
Well, we know that they have two main effects. Firstly, while they're present in the atmosphere, they can kind of interact with incoming solar radiation, the energy from the sun essentially, and kind of perturb its path so that it doesn't make it to the Earth's surface and it scatters it. But additionally, and what we're most interested in looking at here, are the role that these particles play in brightening the clouds that are above the forests. And they do this because when they're in the atmosphere, they grow and they get to a certain size where they're able to form cloud droplets. And the more of these droplets that there are in a cloud, the whiter and brighter that it becomes. And that means that it will reflect away more of the incoming solar radiation that's falling on that particular part of the Earth's surface.
That's amazing. So if you've got an area where you've got a lot of trees in a forest and they're producing these volatile organic compounds which produces particles, you're likely to see then brighter, whiter clouds above them. It's sort of, they're producing their own clouds then, aren't they? Or brighter, whiter, fluffier clouds.
Essentially, yes. I mean, there's a number of other processes that govern the actual formation of the clouds. But what we're interested in looking at is just how significant the impact of these particular particles are on the cloud, how much of that effect we can credit to the original compounds that are released by the trees, essentially.
What would a brighter, whiter cloud then do for a forest? Because normally nature has a way of, what's in it for them sort of thing. There's normally a beneficial effect for the forest perhaps, but maybe not necessarily on our climate, or is it beneficial to both the climate and the forest?
Well, we think that these particles are beneficial to the forest because of the way that they scatter the radiation as it comes in. It's scattered into different directions. It means that more of it's available for the leaves of the trees to use. And that's something that we think is really quite important. As for the climate, the problem that we've got at the moment with climate change is that there's an imbalance, really, in between the amount of solar energy that's coming into the Earth system and the amount of energy that's allowed to escape from the Earth system through the atmosphere. And the more carbon dioxide and other greenhouse gases that we have in the atmosphere, the less of this radiation that's allowed to escape. So the main way that we're trying to address this is by reducing greenhouse gases in the atmosphere, allowing more of the radiation to escape. But something else that we can do is try and reflect away more of the sun's radiation so that less of it gets in the first place. And that's another way that we can address this energy imbalance.
Because a whiter cloud will reflect more solar radiation.
Yes, essentially. So what we're trying to do is quantify this effect using computer simulations so that we can understand exactly the impact that forests are having on the Earth system at the moment.
Catherine Scott from the University of Leeds chatting to Sue Nelson about the impact of forests on clouds and climate. And that's the Planet Earth podcast from Planet Earth Online. Do follow us on Facebook. I'm Richard Hollingham from the Norfolk coast. We're getting sandblasted by the beach in this wind. Thanks for listening. Bye.